first order, zero order, and this term is a non-homogeneous term. So the entire system could be described with a differential equation. The input is the force applied to the object. So if we apply a huge force, or we use an applied pulse force to the object, the motion of the object would be totally different, because this time the force we apply to the object is what? Is input. F is input, and the output is the solution of particular solution. So here, the X, the general solution equals to homogeneous term, and particular solution X1. And the non-homogeneous term, in other words, is an input, will cause the formation of the SP, is a particular solution of the function. So we can, so it could be the output. This term is input. So if we want to describe the motion of the object, we really need what the force is, because the input will determine the SP term, and the general solution will require the homogeneous solution plus the particular solution to well describe the general solution. Okay, and people would like to know, is it a special case or is it a universal case? The answer is that it's a universal. So we can look at the other example in the textbook on electronics. Okay, let's look at the representative circuit. It's a closed loop. So similarly, if we use the energy conservation view, so in a closed loop, the EP equals to the voltage drop of the R plus voltage drop of C and B L is a three representative elements in electronic circuit. It's called the resistance, capacitance, conductance, 电阻、电容 变改。Okay. So here, for most material science students will be familiar with C capacitance because we are good at how to fabricate high quality capacitance. So it's an ability to evaluate the storage of a charge. So okay. So here, in a closed loop, so we share the current I. So I equals to the rate of the dq. So and q equals to C times Vc. So it equals to C Vc dot, right? So here, according to Ohm equation, Vr equals to I for the element of resistance, and VL equals to I. So okay, so here we just plug in this term into the equation. So it equals to RC, VC, VC dot, and the VC plus LC, and VC double dot for second order derivative. So as you can see, it's a second order. It's a first order. And R, C, L are constant, right? So all of these will follow. The equation will be constant coefficient, high order, non-homogeneous differential equation, right? So if we want to understand the element in a circuit, for example, if we will solve the high order ODE, we would VC equals T equals to homogeneous solution plus particular solution. And please notice that the input here, the input will determine the output. And the general solution would be composite with a homogeneous solution and particular solution, right? So here, okay, they would need to, it's common to study the issues that if the ET, the function, the input could be sine wave, could be triangular wave, could be delta function, could be any kind of composite function, right? And with a specific delay time. So you can involve or artificially that some input into the circuit, and you need to understand how the element inside the circuit behave with respect to the time, right? So how can we understand this? We need to solve the high order ODE, and the input will cause the relation, will determine the VP, right?